Good afternoon, sir.
Okay, the recording of the meeting is now on. So let's continue. So beta, yesterday we had done first two methods of celestial position fixing. So before we proceed to other methods, any doubts, queries, or problems you are facing in those two methods, you can share with me, and then we can proceed ahead. Okay, all right. So everything looks in order. So beta, for today, you can keep almanacs with you, nautical almanacs. And if you have Norris tables with you, you can keep those Norris tables also close by. If you don't have them, it's okay, it's perfectly fine. There is only one table which I want to show you. That is the X meridian table. So I will show you on the presentation also. But if you have it with you, then it will be good if you can keep it close. Okay. ओके
सर ये जो लॉन्ग बाई क्रॉन का लास्ट में जो स्केच बनाना है एक बार दिखाएंगे, स्क्रीनशॉट लेना सर.
या ओके बेटा, दिस इज द वन.
सर इसमें ये जो डीआर लेट और डीआर लॉन्ग था, ये वाला दिखाना जरूरी है. डायरेक्ट डीआर लेट और ऑब्जर्व लॉन्ग पे ये सेकंड वाला पोर्शन नहीं बना सकते?
या दैट्स राइट बेटा, आई विल टेल यू. दिस इज व्हाट इज रिक्वायर्ड.
Yes, sir, exactly.
ये जो मैंने बना दिया है, हाईलाइट कर दिया है, दिस इज व्हाट इज एक्चुअली रिक्वायर्ड फॉर प्लॉटिंग द पीएल. जो ये डीआर लॉन्ग मैंने शो किया है, दिस इज जस्ट फॉर योर रेफरेंस टू अंडरस्टैंड दैट द डीआर लॉन्ग वुड बी एट सम अदर प्लेस, द ऑब्जर्व लॉन्जिट्यूड वुड बी एट सम अदर प्लेस. So this is not required to be shown in the plot or in the diagram.
और सर ये एजिमुथ भी रिक्वायर्ड है या नहीं है सर? डायरेक्ट पोजीशन लाइन भी खाली स्ट्रेट लाइन शो कर सकते हैं ना, ये 008 और 180?
Not mandatory. अगर आप बना सकते हो, you should make it. But even if it is not there, it should be fine.
डायरेक्ट एलओपी सिर्फ लगा दे.
Right.
ये सिर्फ एक एग्जांपल के तौर पे है ना सर? इसकी मेजरमेंट वगैरह नहीं चाहिए ना कुछ भी सर?
बेटा देखो, ये जो कॉन्सेप्ट है ये दो जगह पे यूज होगा. एक तो ये यूज होता है जब आपके साइड सॉल्विंग के क्वेश्चन आते हैं. लेट्स से उन्होंने आपको एक सेक्टेंट ऑल्टीट्यूड दे दिया, बाकी की इंफॉर्मेशन दे दी, आपने लॉन्ग बाय क्रोन फॉर्मूला लगाया और ऑब्जर्व लॉन्ग कैलकुलेट किया. Now, in these type of questions, you just need to make a rough diagram. Okay, so आपने सिर्फ एक rough diagram बनानी है. The angles, they need not be accurate or to the scale or measured. Okay, that's a rough diagram only. अब यही चीज अगर आपको आती है प्लॉटिंग के क्वेश्चन में. प्लॉटिंग के क्वेश्चन में they will not tell you to calculate the longitude. They will give you the observed longitude and they will give you the azimuth and the DR lat and you require to plot it. तो उस क्वेश्चन में हमें इसी चीज को to the scale बनाना है. Means all the angles should be correct, the latitude, longitude should be correct, they should be at right angles to them. So plotting में it needs to be exactly as per the scale. तीसरे एक जगह पे कॉन्सेप्ट तीसरी एक जगह है जहाँ पे ये कॉन्सेप्ट यूज होता है, दैट इज चार्टवर्क. चार्टवर्क में भी आपको सेलेस्टियल पोजीशन लाइन दी जा सकती है. So if it is given to you in Chartwrok, then again you need to make it exactly at that particular latitude and longitude. The azimuth should be drawn to the required angle by using parallel ruler and compass rose, and the position line also should be accurately positioned. So plotting और Chartwrok में ये to the scale बनेगी diagram. As far as this question is concerned, जहाँ पे हम calculation कर रहे हैं observe long की, this is only a rough diagram and is only required for reference. Okay. So this was longitude by chronometer. अब हम बेटा अपने third method पे चलते हैं. Third method for celestial position fixing, that is intercept method. Intercept method is the most versatile method of all. Why would I say most versatile? It does not suffer from any limitation. It is by far, I would say, it is the best method which we have. The reasons are, number one, it does not suffer from any limitation. Like Marpas can only be used once in a day when the body is on your meridian. Intercept can be used at any other time, anytime, before Marpas, after Marpas, body close to the horizon, body close to the meridian. In any case, the intercept method can be used. If you compare it with long by crone, now long by crone has one limitation. We can use long by crone before Marpas and after Marpas, but there is one limitation which longitude by chronometer has. That limitation is that long by crone method should not be used when the body is close to the meridian. So let us say, for example, sun. The Marpas of sun occurs around noon time. So close to noon, if you want to take the site of the sun, and it is not meridian passage, it is either before Marpas or after Marpas, then in that case, longitude by chronometer method should be avoided. So that's a limitation which the long by crone method has. Intercept has got no limitation like that. Intercept can be used in any condition. इसके बाद भी हम दो मेथड करेंगे. एक मेथड आएगा एक्स मेरिडियन. एक्स मेरिडियन मेथड कैन बी यूज्ड ओनली इन अ सर्टेन विंडो, जिसको हम लोग बोलते हैं एक्स मेरिडियन लिमिट. Intercept does not suffer from that limitation. Intercept can be used at any time of the day. And पांचवा मेथड जो हमारा आएगा पोलारिस, that method is applicable to only one single body, that is the pole star. Intercept can be used with any celestial body. So as far as a navigator is concerned, this is the best method for position fixing. So let's see what this method is and how do we obtain a position line using the intercept method. So first of all, let's see what all information is provided to us in the question. The information provided is exactly the same which was provided in long by crone. Okay, so in info provided, you have the date and time. Time could be either GMT time, or in some rare case, it could be chronometer time. Wherever they give you chronometer time, they will also give you a AM PM indication so that you can resolve the chronometer ambiguity. Along with this, they will give you the extent altitude and the index error and height of I. Index error, height of I is required for altitude correction. Now, along with this, they will give us the DR position. So you see, this is exactly the same information which was given to us in long by crone. In fact, both these methods are interchangeable. Wherever you can use long by crone, you can use intercept also. And one doubt now comes to my mind. I have just now told you that wherever we can use long by crone, we can use intercept also. So if we use long by Crohn and if some other person uses intercept for that same site, will they get the same PL or will they get different PL? What do you think? If one person uses long by Crohn, another person uses intercept, will they get same PLs or different PLs?
So I think PL will be same.
सर PL तो same आएगी.
सर PL डिफरेंट आएगी, पोजीशन लाइन विल बी डिफरेंट क्योंकि उसका एंगल है, पर द आइडिया इज कि अगर दोनों को कंस्ट्रक्ट दोनों को 2 PL को जोड़ेंगे तो पोजीशन बिल्कुल सही आएगी.
Yeah, okay. So I will explain it to you. We will make a diagram and I'll show it to you. Whichever method you use, whether you use long by Crohn or you use intercept, if it is worked out basis one single site at the same time, so the PL will be the same. Only thing is the reference point for drawing the PL will be different, but the line which you get on the chart will be exactly the same. I will show you with a diagram after we do this method. Okay, so this is the information which is provided to us. Now let's see how do we go about solving the intercept question. Now the beginning is exactly the same as we did in long by Crohn. First of all, we find the hourly GHA of the body from the daily page. You apply the increment for minutes and seconds from the increment table. You apply the V correction if it is required for that body, and you get the accurate GHA of the time of observation. So that's the first step. You apply the DR longitude and you get the LHA of the body. Now this LHA will also give you the value of P. So if LHA is less than 180, P is equal to LHA. If LHA is more than 180, P is equal to 360 minus LHA. So along with this, in the almanac, you will find the declination of the body also. So you note down the hourly declination from the daily page. You apply the D correction increment from the increment table, and you get the correct declination of the body. So same step number 1, what we did in long by Crohn. The second step is also same. The second step we did altitude correction. Again, we apply the index error, which is given to us in the question. We apply the dip correction. This is the height of eye, which is given to us. This gives us the apparent altitude. We apply the total correction, and we get the true altitude of the body. Now, once you have done this much, you have the true altitude, you have the LHA, P, and the declination. You are ready to enter into the intercept formula. So what is this intercept formula? Okay, before the formula, from the true altitude, you get the TZD of the body, true zenith distance, which is 90 minus true altitude. So after this, we apply the formula. This is the formula of intercept. Cos of TZD is equal to cos P, cos lat, cos dec, plus minus sin lat and sin dec. Now the first doubt which will come to your mind, what is this CZD? Till now, we have seen two zenith distances. One is true zenith distance, which we know is 90 minus true altitude. So the true zenith distance. True zenith distance is obtained from the observation. If you get the altitude of a body, 90 minus true altitude gives you the true zenith distance of the body. Then the second zenith distance I told you was MZD, meridional zenith distance. And I told you that meridional zenith distance is nothing but the TZD only taken at the time of Marpas. So if you obtain the zenith distance of a body when it is on your meridian, it is called as MZD, meridional zenith distance. Now, what is this CZD? Now, normally the zenith distance of the body is obtained from a observation. We observe the body by the sextant, we get its altitude, 90 minus altitude gives us the zenith distance. But there is another method which is available to us, which we can use to get the the zenith distance of the body, and that is by using this formula. The intercept formula is basically a formula to calculate the zenith distance of any celestial body at any time for any observer. So using this formula, if I tell you today is 5th of February, so if I tell you whatever our location is, at our location, what will be the zenith distance or altitude of the sun tomorrow at same time? So tomorrow noon, what will be the altitude of the sun at our location, at our position? It can be calculated using this formula. So with this formula, we can calculate the altitude of any celestial body at any particular time for any position or for any observer on the Earth's surface. And the true altitude or the zenith distance which we obtained from the formula is known as calculated zenith distance, because you have obtained it by calculation, not by observation. So how can we obtain the zenith distance by the formula? The formula is cos of P multiplied by cos of latitude. P, you see, we have already calculated. We have obtained it from the almanac and using our DR longitude. Latitude is given to us in the DR position, and declination of the body is also we have obtained from the almanac. So all these things can be put in the formula. Then we have a plus minus sign. Now whether to use plus or minus is decided by the name of latitude and declination. If both are of the same name, we use the upper sign. If both are of the opposite names, we use the lower sign. So in this case, latitude and declination, same names, we use plus. Latitude and declination, opposite names, we use minus. So once you apply this formula, you will get the calculated zenith distance of the body. Now, once you get the calculated zenith distance, what we do now is we find out the difference between TZD, true zenith distance, which we obtained by observation, and CZD, the calculated zenith distance, which we obtained by the formula. So we find out the difference between them, and this difference is what we call the intercept. So intercept is nothing but the difference between the true zenith distance and the calculated zenith distance. Okay. Now, once you find out the intercept, that is the difference between TZD and CZD, we have to give it a name. Intercept is named in two ways. Either it is named towards the body or it is named away from the body. Now, how do we find out whether the intercept is towards the body or away from the body? For that, we can use a shortcut method. I will also tell you the concept behind this method little later, but first let us see how we practically do it. So you use a shortcut method, which is TTT method. Okay. So naming of the intercept is possible or can be done using this shortcut method, TTT method. What is this TTT? First T stands for true. Second T stands for tiny. Third T stands for towards. Okay. So true, tiny, towards. What is the meaning? If the true zenith distance is tiny, tiny means it is smaller, the intercept will be towards. And if the true zenith distance is not tiny, then it will be away. So true, tiny, towards. Just remember this TTT and it will help you give the appropriate name to the intercept. So it will be named either towards the body or away from the body. Okay, once you have done the naming of the intercept, the next thing which we need to obtain for plotting our PL is the direction of the position line. Now for direction, we use the same method which we used in long bicrone also. That is, we calculate the azimuth of the body using the ABC method. So A tangent latitude upon tangent P, B tangent declination upon sine of P, and their combination gives us C. And we use C in this formula, tan azimuth is equal to 1 by C into cos lat, and we get the azimuth. The azimuth is in the quadrantal notation. In the quadrantal notation, the initial north and south is decided by the name of C, and the last east and west is decided by LHA. If LHA is less than 180, you put a west in the end. If LHA is more than 180, you put a east in the end. So when you get your azimuth from here, the direction of the PL is always perpendicular to the azimuth of the body. So we get the direction of the PL. Now with this, that is the intercept and the direction, the question is complete. Now, once you calculate both these things, we have to make a diagram also. We have to make a plot. So how do we make a plot? The intercept plot is done in this way. For intercept plot, you use the dr latitude. It is given to us in the question. You use the dr longitude, again given in the question. Now, in this dr position, first of all, you draw the azimuth of the body. So whatever is the azimuth of the body, which you have calculated, you plot that azimuth. In this example, we have taken it as 108. Then you see what is the intercept. Now, in this example, they have taken intercept 1 mile towards. So what we have to do is, from the dr position, you go towards the body. The body is here. This is where the celestial body is. So from the dr position, you go towards the body. How much distance you go? Equal to the intercept, that is 1 mile as per the scale which you have. So from the dr position, you go 1 nautical mile towards the body, and whichever position you reach, this position, this is the position from where the PL is going to pass. This position is the one from where PL will be passing, and the direction of the PL will always be perpendicular to the azimuth of the body. So from this point, draw a line which is perpendicular to the azimuth, and you get your position line. This reference point from where the PL is passing is known as ITP, which is intercept terminal point. So this is the point from where the PL is going to pass. Now, normally this ITP point position is not required by us. We can plot the dr, we can plot the azimuth and the intercept, and we can draw the PL straight away. But if in some question they want you to find the position of the ITP, that also can be easily done. You can do it easily by using plane and parallel sailing. So you have the dr position known to you. Use your azimuth as the course and use your intercept as the distance. So with azimuth as your course and the intercept as your distance, you can apply plane and parallel sailing, and you will be able to find the latitude and longitude of the ITP also if it is required. So in a normal intercept question, this position is not required, only required if it is asked in the question to free from. Okay. So beta, any doubt which you feel like in this method? If you want, you can take a screenshot of this slide. It will immediately give you the step-by-step method how intercept is to be calculated.
सर ये जो लॉन्ग बाय क्रॉन और इंटरसेप्ट के क्वेश्चन है बुक में, इसमें सर क्वेश्चन पढ़ने में तो डिट्टो सेम ही है, तो ये पता कैसे चलता है कौन सा मेथड से सॉल्व करना है, या पूछा होता है क्वेश्चन में कि इंटरसेप्ट से करो या लॉन्ग बाय क्रॉन से करो?
ओके, अब बेटा सेकंड मेट्स तक तो ये काम बड़ा आसान है. They will tell you which method is to be used for side solving. हमारे क्वेश्चंस में ऐसा पॉसिबल है that they may not give you the method. Okay, they may not tell you the method. कि किस मेथड से हमने इसे सॉल्व करना है. So then the choice is up to you which method you want to use. There are some scenarios जिसमें हम कोई पर्टिकुलर मेथड को यूज करते हैं. तो वो सिनेरियोज जो है वो मैं आपको पांचों मेथड करने के बाद बताऊंगा. अगर क्वेश्चन में हमें बिल्कुल भी कोई इंडिकेशन नहीं मिल रही कि कौन सा मेथड यूज करना है, लॉन्ग बाय क्रोन या इंटरसेप्ट, तो फिर हम उन लॉजिक्स को यूज करके मेथड को फाइंड आउट कर सकते हैं. तो लेट मी कवर अप एक्स मेरिडियन एंड पोलारिस, देन आई विल टेल यू हाउ टू फाइंड द मेथड इफ इट इज नॉट मेंशन्ड और स्पेसिफाइड इन द.
ओके सर, कॉपी, थैंक यू.
ओके, or beta, any more doubt coming in intercept, in the working, how do we calculate it?
So ये प्लस माइनस वाला एक बार दोबारा बता दो.
Okay, beta, in these formulas, wherever you have this kind of a sign, plus minus or minus plus, it could be anything. In long by Cron it was minus plus, in intercept it is plus minus. Okay, let me show you the long by Cron formula also. See, this was the long by Cron formula. You had a minus plus in this. So wherever you get this kind of sign, just see the term which is following this. See, in this term you have latitude and declination. Whenever latitude and declination are of the same name, both are north or both are south, you always use the upper sign. And whenever they are of opposite names, you use the lower sign. Okay, so in long by Cron, if lat and dec are of same name, you will be using minus. Let's see in intercept how it happens. In intercept, you see, if lat and dec are of the same name, you use the upper sign, which in this case is plus.
ओके सर, ठीक.
ओके, और बताओ बेटा, और क्या डाउट आ रहा है? Okay, very good. So this covers up the intercept concept. We have seen the intercept PL also. This is how we draw the intercept position line. Okay, in case the intercept is away, let us take for example that the intercept was away. The same intercept 1 nautical mile away. Now in this case, you draw the azimuth of the body. This is the direction where the body is. Now from the DR position, you have to go away from the body. So you move in reciprocally opposite direction, away from the body. So whichever direction the body is, you move away from it. How much distance you move? Equal to the intercept. So from the DR position, you go 1 mile away from the body and you will get your ITP. Once you have your ITP, the direction of the PL is perpendicular to the azimuth of the body. So that's how we draw the intercept if it is away. Okay. So shall we proceed on to the next method, beta?
Yes, sir.
Okay, this we will do a little later. Now, I told you that if you use intercept method or you use longitude by chronometer method, in both the cases, the position line which you obtain is the same. So let us see how is this possible. Now, if you use a long by chron method for solving position line, you use a longitude by chronometer method. If you see in this diagram, this is our dr latitude and this is our dr longitude. So when we calculate the site using long by chron, we will obtain an observed longitude. So you see, this is the observed longitude which we have obtained. So we will draw the observed longitude. Now this is our reference point from where the PL is going to pass, Bravo in this case. We draw the azimuth of the body and perpendicular to the azimuth is our PL. So you obtain the PL in this way. Now, if somebody has used intercept, what will happen here? For intercept, he will be plotting the dr latitude. He will be plotting the dr longitude. The dr position is plotted. Then he will plot the azimuth of the body. Now, the value of the intercept which he is going to get will be such that when he plots it, now in this case, the intercept will be away. And when he plots this intercept, he will see that the ITP exactly come on the same position line which we obtained using long by chron. So whether you use longitude by chronometer method and plot it, which is plotted in the blue color, or you take a intercept or you use the intercept method and plot your position line, which in this case is the yellow plot, you will see that both these methods will give you the same position line. So by changing the method, the position line will not change. If it is the same body and it is the same time, whichever method you use, whether you use long by chron or you use intercept, in both the cases, you will receive the same position line. If you want to get a different position line, you have to either change the body or you have to change the time. If there are two bodies available to you, you take sight of the second body and you will have a different PL. If only one body is available to you, you take the sight of the body after some time and the PL would be different. So at the same time, using the same body, any method which you use, the position line is going to remain the same.
So one more thing, the formula for A and B, as per that, in any case you solve by either by longer by chron or intercept method, the values of A and B is going to be the same only in both the cases. As per that.
A and B, that is azimuth beta for azimuth?
Yes. So azimuth also will be same as per the basis the formula also, if we see.
Right, beta, right. In both the methods, you see azimuth calculation is exactly the same.
Exactly. Only if the time changes, then only the values for A and B will change.
Yes, that's right.
Right.
Okay. So this was the concept of intercept versus long by chron. Okay. Now the next method which we have is the X meridian method. Okay. So what is this method X meridian?
So when body is near the meridian.
Very good. तो इसको याद रखने का सबसे इजी तरीका है, हम लोग बहुत अपने लैंग्वेज में यूज करते हैं ना एक्स. व्हाट डू वी मीन बाय एक्स? पीपल आर लुकिंग फॉर देयर एक्सेस ओवर सोशल मीडिया.
मेरिडियन से थोड़ा सा पहले या थोड़ा सा बाद.
ओके, राइट, दैट्स राइट. तो बेटा एक्स का मतलब होता है जो छोड़ के चला गया या जो छोड़ के चली गई, दैट इज एक्स. तो यहाँ पे जो बॉडी है वो मेरिडियन को छोड़ के चली गई. ओके, तो बॉडी इज नॉट ऑन द मेरिडियन बट क्लोज टू द मेरिडियन. So that is known as X meridian site. Now, this method X meridian was important in the olden days when we were not having GPS and we were dependent upon celestial position fixing. Nowadays, this method has more or less become redundant, and I don't anticipate that any of you will be using the X meridian method at all practically on ship. However, for the exam purpose, this method is very much applicable, and many a times question comes which are based on this method. Practically, this method has become redundant. Number one, we have the GPS available to us. So it is not very important for us to have the MRPA site or a site close to noon. We can have a site little later or little earlier, even if there is a interruption. Let us say there are clouds in the sky, or there is a shower of rain or fog, and you are not able to take the noon site. Now, in the olden days, we tried to cover it up by taking a X meridian site. Nowadays, you can wait, and whenever the sun appears from the clouds or whenever the rain stops, the site can be taken at that time. So practically not very useful method nowadays. Why was it important in olden days? Because noon time was fixed for fixing the position of the ship. We made our noon report basis the noon position. So if at the time of MRPAS a site was not possible, or you missed the MRPAS time because of any reason, then it was possible for you to still calculate the observed latitude using this X meridian method. So let us see how do we use this X meridian method. Now, X meridian method can only be used in a certain window period. That window period is known as X meridian limit. It is denoted in minutes of time. If I say the X meridian limit for sun for today is 15 minutes, that means you can only use this method 15 minutes before MRPAS and 15 minutes after MRPAS. That is the meaning of the X meridian limit. So if you happen to go outside that window period, that means more time has passed, more than 15 minutes have passed, or the MRPAS is going to occur at a time more than 15 minutes later, then X meridian method cannot be used. So which method can be used in that case? Which method can be used better? If we are outside the X meridian limit, which method will you prefer?
Intercept.
Yeah, that's right. So if X meridian is not possible, you are outside the limit, then you can use the intercept method instead. Intercept can be used even when you are within the X meridian limits also. Intercept can be used anywhere. Now, how do we calculate this X meridian limit? I will tell you about calculating the limit a little later, okay? Because in the questions, you are not required to calculate the X meridian limit. They will straight away tell you that this question has to be done using X meridian method, and you solve it. So let us first see how do we calculate this PL. Then later on, we will see how do we obtain the X meridian limit if it is required practically. So whatever information was given to us in long by Cron and intercept, the same information is given to us in X meridian site also, with one extra information. They will tell us that the body is close to the meridian or the body is near the meridian. If they mention this term in the question, then it is understood or it is accepted that this question is to be solved using the X meridian method. So it's a practice in navigation that if it is mentioned that the body is close to the meridian or near the meridian, you can use the X meridian method to solve it. You don't even need to check whether the body is within the X meridian limit or not. You can simply mention there, since it is explained or mentioned in the question that the body is close to the meridian or near the meridian, using the X meridian method to solve it. So they will provide us with the date and time. The time could be either GMT or in some rare cases chronometer time with the indication of AM PM. They will tell us that the body is close to the meridian or near the meridian. This phrase only tells us that the question is to be solved using the X meridian method. They will give us the sextant altitude of the body and the index error and height of phi, and they will give us the DR position. So this is the information provided. Step 1 is the same here. You go to the almanac, you calculate the GHA. So find out the GHA of the body, apply the DR longitude and get the LHA, which gives you the value of P. Second thing which you calculate or obtain from the almanac is the declination. The second step is also same. You correct the altitude of the body. So you apply the index error, you apply the dip correction, this is height of phi, you get the apparent altitude. We apply the total correction and we get the true altitude of the body. Now 90 minus true altitude gives us the true zenith distance of the body. This is all the information which we require for entering into the X meridian formula. What is the X meridian formula? Cos of mzd is equal to cos of tzd plus 1 minus cos p into cos of latitude, cos of declination. So you see all the data which is required on the right hand side is available to us. We have the tzd, we obtained it from the true altitude. We have the value of p is already calculated. We have the latitude, it is given to us in the question. We have the declination which we obtained from the almanac. So we put all these values in the formula and we obtain the MZD, meridional zenith distance. So you see in Marpa's question, this MZD was obtained straight away from the sextant altitude or the meridian altitude of the body. 90 minus altitude gave you the MZD straight away. But here, since we are not able to take the site when the body is on the meridian, we are taking it either before Marpas or little bit after Marpas. So the zenith distance which we are getting is not MZD, it is TZD. So when we put this TZD value in the formula, we can get the MZD of the body. Now, once you get the MZD, the procedure is similar to Marpa's question. You get the MZD from here, you combine the MZD with the declination, exactly as you did in meridian passage. So we name the MZD using the shortcut method, which we discussed yesterday. We combine it with declination. That means if they have same name, they are added up. And if they are of opposite names, one is subtracted from the other. The smaller one is subtracted from the bigger one. And you obtain the observed latitude. Okay. Now, up to here, it was similar to Marpas. Now comes the difference. In Marpa's question, once you get the observed latitude, the question finishes there. But here, after you get the observed latitude, you have to find the azimuth of the body also. So we find the azimuth using ABC. Now, why is this azimuth required? Now, this azimuth is required because the observed latitude is not our PL. Okay, the PL will not be running east-west. The PL will always be running perpendicular to the azimuth of the body. Since the body is not on the meridian, the azimuth is not going to be north or south. The azimuth is going to be something else. It will be close to north or south, but it will not be exactly 000 or 180. So whatever azimuth we have, the PL is going to be perpendicular to the azimuth of the body. So then what is the use of this observed lat? Observed lat gives us a reference point from where the PL is passing. So let me show you how do we draw the PL. So in this question, we draw the PL using the observed latitude, the TR longitude. This is our reference position. And at this position, we plot our azimuth. Perpendicular to the azimuth lies our position. So you can see here the PL is not running east-west. The PL will be perpendicular to the azimuth of the body. Okay, so this is clear, beta. This X meridian method is clear. Any doubt coming to your mind related to this? Okay, good. So if you want, you can take a screenshot of this slide. This has the formula as well as the complete method stepwise. How do we solve a X meridian question?
Sir, if you differentiate this, can you differentiate TZD and MZD through the diagram?
Okay. इसके लिए बेटा हमें बनानी पड़ेगी रैशनल होराइजन डायग्राम. Okay, what we will do is, let's take a break now and we meet back at 45. Then I'll show you, I'll make a diagram on the rational horizon plane and I'll show you what is the difference between MZD and TZD.
Okay, sir.
Okay. Okay, so let's meet back at 45.